All right, so this is just a quick example of both of our classification methods that we encountered this week. I'm going to start with logistic regression and just look at a little data set that has information about credit status. So we have four variables here: default, student, balance, and income. These should be fairly self-explanatory. These are whether or not somebody is a student, whether or not they defaulted on their credit card, what their balance that they were carrying on their credit card was, and the income, their income. So the idea is that we want to see if these are indicative of, or if we can build a classifier to use maybe balance or income to decide whether or not somebody would default on their loan. This is what we're trying to predict, except for this time, rather than like we saw with linear regression, it's a binary variable, like yes or no, right? So first, let's take a look at how this shakes out, whether or not like somebody defaulted based on their balance and whether or not somebody defaulted based on their incomes. So the incomes don't seem to be very different, except for that there's a little bit wider range in the no's. But with the balance that people were carrying, it seems to be more indicative of a difference between groups as to whether they defaulted or not. Similarly, we can sketch a plot of both of those variables, balance and credit, together and color the points based on default. And we see that the x-axis seems to be, which is balance, seems to have a bigger difference or make a bigger difference in determining the boundary between those groups. If we just make a plot of whether or not those are yeses or nos, whether they're zeros or ones, right, and have our balance values across the x-axis, we see those two different groups, and you see that there is maybe some separation in between here. Again, what we're talking about with logistic regression is we're going to use probabilities of class inclusion. So if we go ahead and create a logistic regression classifier, plug in our x's as the balance, and we're trying to predict whether or not remember we created a binary variable based on the default status here. So that's what we're predicting, and then we get an intercept and a coefficient, and remember that those were the those were the slope and intercept of that that exponent in the denominator of the logistic function. So we can define a function based on that, and what we see is that S-curve, we should see an S-curve that comes back in here and breaks down at what point, like what the probabilities of the different values based on balance are for these class inclusions. So for example, like my model, if I say what's the likelihood, what do I think somebody who carries a balance of $1,000 would be? Well, it seems that my model predicts that they won't default. And the likelihood that my model predicts they won't default is 99%, whereas they think that they will default not quite 1%. So I'm going to go ahead and create the predictions for all of these balance values. And then we can look at a plot of that, and here we go. We see that curve of probability values. And this point here is the likelihood of somebody who's $1,500 balance being in either class 0 or class 1. Well, this is in class 1. The likelihood that they would default is about not quite 10%. So we would say that they're in the not default group. We can look at a couple of other examples, specific examples so here we have $1,000, $1,500, and $2,500, and these are the likelihoods again, and it makes sense. Like the 35, I should just change this to 3,500. The 3,500 is much more likely to default. That's what we're saying here, and that should make sense. That's actually 2,500. Sorry, let me just change this to 2,500. Okay, 92% likely that they will default. This is a different idea than what we have with KNearestNeighbors. So what KNearestNeighbors is going to do is, the way that this will work is it will take in a balance value, and based on the nearest neighbors to that, the other variables that are closest to that. So maybe like if we plug in 700, it's going to find the maybe 5. We'll use n neighbors of 5. It'll find the 5 nearest points to that and use the majority class values of those 5 points. So by fitting a KNearestNeighbors model with n neighbors of 5, this is going to determine the class values of the 5 nearest neighbors of all of the input values. So then if I make predictions based on this, you see that I get class values back. But the way that these class values were determined was based on a nearness to other points, as opposed to a likelihood of class inclusion, as we were doing with the logistic example. And if I plot a scatter plot of those predictions, we see how that class inclusion was understood by the KNearestNeighbors model. So there's it's the same question that we're asking, but it's decided differently. These two models determine the answer differently, but they're both going to tell us whether or not we believe that somebody with some sort of quantitative input belongs to one class or another. So similarly, we can use logistic regression in this example to even look at this, the student status. And the only thing I'm going to do is I'm just going to convert the student to a dummy 0 and 1 and use that to predict whether or not somebody defaulted. So similar kind of problem. It's just that our data this time is binary data as well. And so you see that we're inputting just a series of 0s and 1s into our data frame. And now we get an intercept and a coefficient here of -3, and we can talk about what the likelihood of somebody being a student or not a student and defaulting would be. So in this example, now what we see as a result of our model is predicting that somebody who is not a student will default versus a student who somebody who is a student who will default. They're not dramatically different. 97% and 96% likely. There's a little bit of a difference, and if you plotted a curve, they would be separated just by a little bit, but not a dramatic difference. So there's just a couple of examples of classification on this data set.